Hello, students. Hope you're enjoying the weather. That's my dog in the background. Hey, Sophie. So this is Matrix of Linear Transformation, section 1.9 in the text. And I'll do these notes in two different installments. So for this first one, we will look at linear transformations and look at each column vector as E1, E2, E3. And each column vector, E sub I, will be made up of zeros and ones, 1, 1. So the identity matrix is just a square matrix and has ones along the diagonals and zeros everywhere else. In general, the identity matrix times a column vector is just that column vector, as you see here. So determine A, what is A? If A times the column vector E1 is equal to 2, 5, and A times the column vector E2, or 0, 1, is negative 1, 6. So what this means is A times E sub 1 is Y sub 1, and A times E sub 2 is Y sub 2. A has got to be a 2 by 2 matrix. This is a 2 by 1 matrix, a 2 by 1 matrix, so this is 2 by 2, and made up of x1, x2, x3, x4. So what we have is A times E1 has to be 2, 5, and so as you see, x1 times 1 plus 0 is 2, meaning x1 is 2. And x3 times 1 plus x4 times 0 is 5, so x3 is 5. Likewise, look up here, A times E2 is negative 1, 6. You would do the matrix multiplication and you would come up with x2 is equal to negative 1 and x4 would be equal to 6. So A is easily determined. 2 and 5 are the first column and negative 1 and 6 are the second column. If you know AE1 is Y1 and AE2 is Y2, and they're given. So your turn. Here's E1 and E2 as usual, and then here's two column vectors in R3. So T is a transformation from R2, these are the inputs in 2 dimensions, onto all R3, the inputs in 3 dimensions. And we're going to do two different images. One, find the image of the transformation of 3, 2 into a vector. What is that image? And take x1, x2 and transform it in the same way that E1 gets transformed into Y1 and E2 gets transformed into Y2, and find out what happens there. So AE1 is Y1, set it up. AE2 is Y2, set it up. X is a 2 by 1 matrix. Y is a 3 by 1 matrix. So what are the dimensions of A, such that A times X gives you Y? Yay, hope you got 3 by 2. Okay, so A is a 3 by 2 matrix, so just set out the 3 by 2 matrix. What is that 3 by 2 matrix? As we saw in the last example, the first column will be x1, x3, x5, and the second column will be the 0, 1, 1. Now, what is the image of 3, 2 under the same transformation? So take the A times the column vector 3, 2, do the matrix multiplication, and you get 3, 2, 8. You might notice that 3 times the first column gives you 3, 0, 6, and 2 times the second column gives you 0, 2, 2. What happens when you add the 3 and the 2, and then the 6 and the 2? Aha, look what you get. Amazing. So, in general, we take the A times the column vector x1, x2, and that's just going to be x1 times the first column plus x2 times the second column. You could set it up this way as well with just the x1 and x2. And you notice 1, 0 times x1, x2 will just give you x1. And then 0, 1 times x1, x2 will just give you x2. And then here you would have 2 times x1, 2 times x1, plus 1 times x2, 1 times x2, voila. In general, it is the x1 times the transformation of the first column in the identity matrix, the 1, 0. So this right here is 1, 0, and this right here is the 0, 1. And the transformation of 1, 0 in this situation is this y1 vector. And the transformation of E2 in this particular situation is the y2 vector. Theorem. We have a mapping transformation from Rn to Rm. It's a linear transformation. We know that there will be a unique matrix A such that when the input are all the x's from the domain in the n-dimensional space, you will get a resulting matrix in m-dimensional space. So if the jth column is E sub j, then the resulting vector is just going to be that column in the A matrix. We basically just saw that in the last example. We had a 3 by 2 matrix in the last example. A is made up of the 2 columns, which were the original images of each vector. I'll show you that again. This and this are the original images of this, and that's what A is made up as. Your turn. Find the linear transformation from R2 onto R2, rotating each of the vectors in R2 counterclockwise 90 degrees. So basically start with E1 and E2 and ask, where do each of these go? So E1 is just a vector on the positive x-axis going to the right 1. And if you rotate that counterclockwise 90 degrees, it ends up going up the positive y-axis 1 unit. So it would go to, what is that, 0, 1. So 1, 0 would go into 0, 1. Okay, where would 0, 1 go to? So imagine 0, 1, that's positive y-axis, 1 unit. Rotate that counterclockwise 90 degrees, you end up at the negative x-axis, so negative 1, 0. Here's a picture. E1 is 1, 0, the vector, and it would go up here to 0, 1, identified in red. In black here, E2, 0, 1, goes 90 degrees counterclockwise, would go to negative 1, 0. So once you know that, you have your A matrix, the image of E1 and E2. Then you just want to see the linear transformation. Oh, that is it. That's the linear transformation, A. So AX equals B. So now let's say I want to transform 1, 2. So over 1 up 2, that's a diagonal. Ooh, we can still do that 90 degrees. And you just take A multiplied by the column vector 1, 2, and you get negative 2, 1. And look at that. Right there, it's 90 degrees rotated counterclockwise. Okay, your turn here. Find the linear transformation from R2 onto R2, perpendicularly projecting vectors in 2-dimensional space onto the line. Think about it as y equals x, or x2 equals x1. So ask yourself, where does E1 go? Where does E2 go? So the column vector E1, 1, 0, will have to, it's like 45 degrees up to here. It goes 45 degrees up to there. And if you think about this going over 1 and up 1, think about a square right here. What is the hypotenuse length? Well, 1, 1, root 2. So the whole length is root 2 divided in half, and that will be where this vector ends up. So you go over 1 up 0, and it ends up as halfway along here. That would be root 2. So this would be 1/2, 1/2, and then the, what did I say? This whole thing is root 2. So this part is root 2 over 2. Sorry. So you go over a half, up a half to get to root 2 over 2. Both of them would be doing the same thing. And so this one's coming down to root 2 over 1/2, up 1/2. And so is this one. So the A vector is this right here. And then how would you project, let's say, 2, 4 onto that line? You go over 2, up 4, this point here. Hypotenuse is root 20. And you want to find out, what the point is here. Well, just do the projection. 2, 4. I'm sorry, just do the matrix multiplication, A times 2, 4, and get 3, 3. And that makes sense, over 3, up 3. This length would be 3 root 2, and 3 root 2 squared is 18, and then this length from 3, 3 to 2, 4 is just root 2. So that squared is 2, 18 and 2 is 20, and that's that. I'm going to stop here and maybe do 3 videos. Okay.